This lesson is going to be on rationalizing a denominator. As a general rule in mathematics, we are not allowed to leave a radical in the denominator of any fraction. So the process of eliminating this radical is called rationalizing. It's a simple process, but let's take a look at a background problem to understand what we're going to be doing with this. If I have the square root of x, and if I multiply the square root of x by itself, what we're really left with then is the square root of x squared, since x times x is x squared. However, x squared itself is a perfect square and becomes a normal x. So to kind of conclude this, when a radical is multiplied by itself, our answer ends up being the radicand, or whatever was inside the radicals to begin with. We're going to use this background information to rationalize denominators. In the first example, we have 2 over radical 3. If we use the example that we're shown above, I should be able to multiply the denominator by radical 3 in order to eliminate the radical in the bottom. But I can't just multiply a denominator by something without also multiplying the numerator by it to balance it out. So I'm also going to multiply the numerator by radical 3. What this is essentially doing is it's multiplying the entire problem by 1, because radical 3 over radical 3 is really a 1. So we're not changing the value of it, but we are changing its appearance by using this little trick. So the numerator of this problem is now 2 radical 3, because they're going to multiply together. The denominator is radical 3 times radical 3, or radical 9. If we clean this problem up, the 2 radical 3 will not simplify any further. However, the denominator, we can take the square root of the 9, and it becomes a normal 3. Therefore, the rationalized fraction is 2 radical 3 all over 3. In the next example, I am now going to try to rationalize 1 over radical 2. In order to do this, I am now going to end up multiplying this by another fraction. The radical in the denominator is radical 2, so I'm going to multiply the top and the bottom by radical 2 to help eliminate the radical in the bottom. 1 times radical 2 in the numerator is simply 1 radical 2. And on the bottom, radical 2 times radical 2 is radical 4. I can then take my denominator. The square root of 4 is going to come out as a perfect square. So it is simply radical 2 on top, you don't have to write the 1 in front, over a 2 on the bottom. So radical 2 over 2 is my rationalized fraction. Taking a look at the examples further down the page. This time we have 5 over 3 radical 5. I want to get rid of the radical 5 in the denominator. So I'm going to multiply both the bottom and top by just the radical 5. I do not need to multiply by the 3. I just need to multiply by the radical in this example. In the numerator, that leaves me with 5 radical 5. Again, they don't multiply together because one's a regular number, one's a radical, but we can write them together. In the denominator, the 3 will come along, and radical 5 times radical 5 is radical 25. I can then take the square root of the 25 in the bottom. So 5 radical 5 stays on top. And then it's 3 times 5, because the square root of 25 is 5 on the bottom. This gives me 5 radical 5 over 15. However, the 5 over 15 can reduce. This will reduce down to 1 over 3. So 1 radical 5 over 3 is my most reduced form. Or you could just write it as radical 5 over 3. For example number 4, we are going to multiply the top and bottom again by the radical we see. So we're going to use radical 12. That's going to give me 6 radical 12 on top over radical 144 on the bottom. Now this time I have a radical on top that can simplify down, so I am going to get 6 times radical 4 times radical 3, because 4 times 3 gives me 12, and 4 is my perfect square. On the bottom, radical 144 is just going to become 12. Now, I can take the square root of the 4 on top. That's just going to become 2. And I can multiply the 6 and 2 together to get 12 radical 3 over 12. Conveniently, the 12's in front can divide out and cancel, so this problem leaves me with just radical 3. Now we're going to take a look at a couple examples that use FOIL. And once again, when we go through to do these problems, we're going to look at using double distribution. So I'm going to take my 6 from the first example and multiply it by the entire set of parentheses that comes next. That's 6 plus radical 5. And then I'm going to take the minus radical 5 that comes from the second part of the first parentheses and multiply that by 6 plus radical 5. And now I'm going to do some distribution. 6 times 6 is 36. 6 times radical 5 is plus 6 radical 5. Negative radical 5 times 6 is negative 6 radical 5. And for our last part here, negative radical 5 plus radical 5 is negative radical 25. To clean this up a little bit, the plus 6 radical 5 and minus 6 radical 5 will cancel out to 0 if you add them. The 36 will come down, and radical 25 is just a 5. And I can subtract those two and get 31. In the last example, we are also going to do our double distribution. It is 2 times 2 plus radical 7 minus radical 7 times 2 plus radical 7 as well. 2 times 2 is 4. 2 times radical 7 is 2 radical 7. Negative radical 7 times 2 is negative 2 radical 7. And negative radical 7 times radical 7, we multiply those together, negative 49. As I pointed out before, we know that the middle two are going to cancel out. So these are gone. The 4 comes down. Minus the square root of 49 is 7. And once I subtract those, I get negative 3.